How does observation change particles in the double-slit experiment? Imagine watching a tiny particle like an electron or photon go through a barrier with two tiny slits. When no one is watching, these particles act like waves, spreading out and creating a pattern of bright and dark bands on the screen behind. This pattern is called an interference pattern and shows the wave nature of particles at tiny scales. But if you try to find out which slit the particle actually goes through, things change. Suddenly, instead of a wave pattern, you see two clusters on the screen, like classical particles passing through one slit or the other. This change happens because the act of measuring or observing interacts with the particle. For example, shining light on the particle to see which slit it passes through disturbs it enough to stop it from acting like a wave. The wave collapses into a specific path, and the interference pattern disappears. This is called the observer effect in physics, and it shows how measurement influences what happens at the quantum level. Interestingly, scientists have also done experiments where they delay the observation until after the particle has already gone through the slits. Even then, the pattern on the screen changes based on whether they decide to observe or not. This suggests that particles do not have a fixed state independent of measurement. Instead, they seem to know when they are being watched and change their behavior accordingly. This strange behavior is part of what makes quantum physics so weird and fascinating. It blurs the line between what is real and what is influenced by observation. In the world of quantum mechanics, reality depends on whether or not you are looking, which challenges our usual ideas about how the universe works. This phenomenon is not just a curiosity. It is essential for developing new technologies like quantum computers and secure quantum communication. Understanding how observation affects particles helps scientists control and manipulate quantum states, opening doors to incredible new possibilities. The double-slit experiment remains one of the clearest demonstrations of how strange and counterintuitive the quantum world really is.